Correlation analysis. We all know that statistical relations are different from the exact mathematical relations. It also helps in understanding and analysis of various business problems. In this lesson, we will study the correlation, the Karl Pearson's coefficient of linear correlation, and the Spearman's rank correlation. After going through this presentation, you should be able to define correlation, explain scatter diagram, and describe Karl Pearson's coefficient of linear correlation, discuss the probable error of R, and analyze the Spearman's rank correlation. Correlation is a mathematical concept which describes a pattern of numbers. Correlation is the extent to which two or more things are related to one another or correlated. Numerical description of correlation is a correlation coefficient and pictorial description is a scatter diagram. As such, it may not help to understand what is going on in the real world and also does not tell you why one variable is correlated with another. A scatter diagram of the data helps in having a visual idea about the nature of association between two variables. If the points cluster along a straight line, the association between variables is linear. The strength of the correlation between two variables, such as two stock prices, is measured by the correlation coefficient. If two stock prices have perfect positive correlation, their correlation coefficient will have the value of +1. If they have perfect negative correlation, their correlation coefficient is -1. Otherwise, the correlation coefficient will have a value between -1 and +1. If the two stock prices do not vary together in a consistent manner, their correlation coefficient will have a value close to 0. Correlation coefficient range lies between -1 to +1. If it is -1, then the correlation between variables are perfect negative correlation. If it is +1, then the correlation between variables are perfect positive correlation. If it is 0, then there is no relationship between variables. Probable error can be used to specify the limits of population correlation coefficient, RHO, which is defined as R minus P dot E brackets R and R plus P dot E bracket R, where PE denotes correlation coefficient in population and R denotes correlation coefficient in sample. If R is less than 6 PE brackets R, then correlation is not significant. If R is greater than 6 PE brackets R, then correlation is significant. Find out correlation between salary and working habit from the following information and also its probable error. Data is given in the table. X denotes salary per month, Q the number of days worked in a year, and P is the usual days of working. Y equals to P divided by Q multiplied by 100. The formula for correlation is Rxy equals to sum of x minus xi and yi minus y divided by square root of sum of xi minus x to the power 2 and square root of sum of yi minus y to the power 2. First calculate x bar by adding all 6 observation of x, which equals to 105. Then divide by 6, it equals to 17. Calculate y bar by adding all 6 observation of y, which equals to 240, and then divide by 6, it equals to 40. Calculate x minus x bar and y minus y bar. Also calculate the square of each element of x minus x bar and y minus y bar. Also calculate multiplication of x minus x bar and y minus y bar. Put all values in the formula and calculate correlation, which equals to minus 0.99. Next, we have to calculate probable error. Put all values in the formula. Here, n equals to 6, r equals to minus 0.99. Therefore, probable error is 0.0055. The coefficient of correlation obtained on the basis of ranks is called Spearman's rank correlation, or simply the rank correlation. When the given data consists of some extreme observations, the value of Karl Pearson's coefficient is likely to be unduly affected. In such a situation, the computation of the rank correlation is preferred because it will give less importance to the extreme observations. It is used as a measure of the degree of association in situations where the nature of population from which data are collected is not known. The following tables gives the marketing expenses made by 10 companies and their respective sales revenue. Calculate the rank correlation. Marketing expense 35, 90, 70, 40, 95, 45, 60, 85, 80, 50. Revenue from sales 45, 70, 65, 30, 90, 40, 50, 75, 85, 60. Here X denotes marketing expense and Y denotes revenue from sales. For calculation of rank correlation, first rank the values of X and Y and mark them as Rx and Ry. After that, calculate the difference between Ry and Rx and mark them as D. Then square each value of D, then sum of D square, then put all the values in formula. Here n equals to 10, sum of D square is 16. The rank correlation is 0.903. The greatest limitation of correlation, one that is often forgotten, is that it does not tell researchers whether or not the relationship is causal. In other words, correlation does not prove causation. It only shows that two variables are related in a systematic way, but it does not prove nor disapprove that the relationship is a cause and effect relationship. Only the experimental method can do that. Now let us check if we have understood the various concepts discussed in this lesson clearly. A scatter diagram is a graph of x and y. Right or wrong? Right. The highest strength of association is reflected by which of the following correlation coefficients? 1.0. Right or wrong? Right. The closer the correlation coefficient is to 0, the greater the predictive validity of a test. Right or wrong? Wrong. Before we end, let us briefly revise what we have studied so far. Correlation is the degree of association between two variables. Scatter diagram is an ungrouped plot of two variables on the x and y axis. Autocorrelation is similar to correlation. It describes the association or mutual dependence between values of the same variable but at different time periods. Autocorrelation coefficients provide important information about the structure of a data set. Correlation coefficient is a number lying between -1, perfect negative correlation, and +1, perfect positive correlation, to quantify the association between two variables. There are several types of correlation coefficients, the selection of which is determined by the level of scaling of the two variables.